Okay, so today we're looking at multiplying a non-unit fraction by a whole number. Okay, so a non-unit fraction is more than one as a numerator. For instance, 3/4 or 6/7. Okay, but our numerator is now more than one. Okay, proper fraction, we've been calling it as well, proper fraction. So yesterday we kind of looked at multiplying a unit fraction, yeah, and we've learned you multiply the top number, yeah, the numerator. So for instance, we started off with 1/4. If we multiplied that by 4, yeah, so 1, 2, 3, 4. So repeated addition, but it's actually multiplying. Okay, so there we see 1/4 times 4 would be 4, and then the denominator stays the same. Okay, and what you can also say that is also equivalent to one whole. Okay, so moving on today, we are going to be multiplying fractions with non-units. So as we've got quarters here, let's set it up as, or let's do 3/4 multiplied by 4. Okay, and just to show you, just to kind of get that visual picture that helps sometimes, if we just dab our lines back in. Okay, so if I shade in 3/4 first, so one lot of 3/4. Okay, is 3/4. Okay, so the second, if we've times it by 4, so let's use a different colour. So if I shade in another 3/4, it takes us to 6/4 or 1.5. If I add another 3/4, the third lot of 3/4, yeah, there we go. Now we've got 2 wholes and 1/4, whoops, and 1/4. So 2 and 1/4, or individually 1, 2, 3, 4, 5, 6, 7, 8, 9. 9/4. And then lastly, the last 4, the last 3/4 added. Okay, now if we count these up, then we've got 4, 8, and 12. Okay, so 12/4. So that's kind of individually adding it up, but kind of our method we looked at yesterday, or our rule down here, yeah, when multiplying a fraction by a whole number, you only multiply the numerator by the whole number. Okay, and if we have a look up here at the one we've done, so 3 times 4 equals 12, yeah, done that bit, and then your denominator stays the same, so 12/4 or 12/4. Okay, so let's have a try with another one. Let's have a look at another one, or let's do 3/5 times 5 equals. Okay, so following on our rule, following on again, so our numerator we multiply by the whole number, so 3 times 5, I know again, if these get more trickier, a bit like last week, I know my 5 times table, but if not, I can just write it down, add 5 each time. Okay, so I've got 3 times 5 is 15, so my 15 gets written there, and then over your original denominator, okay, 15/5. Okay, now again, like yesterday, this is fine, yeah, and our answers are written in this, sorry, our answers are written in this format, yeah, as in proper fractions, but you may then want to turn it into a mixed number, and then both of these actually, you probably notice, convert to whole numbers. So how many 5s in 15? Yeah, there are 3 whole ones. Okay, How many fours in 12? Oh, it's also 3. There we go. And then if I just to kind of visualize that, if we just draw 1, 2, 3 fifths, and again, we use these bar models a lot and really helps our understanding, especially for fractions. They're brilliant for kind of picturing and visualizing it. Okay, so if we were to shade that in as we go, we would have 3 fifths, second lot of 3 fifths, third lot of 3 fifths, fourth lot of 3 fifths. You can see I'm adding 3 each time. Yeah, and altogether they're 1 whole. So I have 15 fifths there, 5, 10, 15. So 15 fifths is also, which is equivalent to 3 wholes. The challenge task today then. If you get onto that, the challenge task, there's kind of missing digits to find, and the last part of it is to try and use all the digits at least once. My tip for that is to go back to this rule and keep going back to this rule. Yeah, when multiplying a fraction by a whole number, you only multiply the numerator by that whole number. Okay, now if you've got some digits missing but they're on the bottom, you might already have a denominator further on. For instance, you might have 2 over something times don't know what, but it equals don't know what here. But this bit is written in. Okay, so if you have a denominator here and we're multiplying by a whole number, yeah, you know this one is going to be the same. And that way, that can start you off on the problem because you can rule out a couple of the possibilities. Okay, so if you get a chance to get onto that challenge task, then just try and bear that in mind as you go along. Okay, good luck today.